If you were to search for the absolute largest single object in the universe, where would you even start looking? The observable universe stretches roughly 93 billion light-years across. That is a volume of space so vast that human comprehension completely breaks down trying to map it. At this scale, Earth and our entire existence amount to less than a microscopic fraction of a rounding error. We are effectively non-existent. Yet within this expanse, there is one structure so massive, it forces us to question if we understand the rules of the universe at all. It is called the Hercules Corona Borealis Great Wall, a cluster of galaxies spanning an astonishing 10 billion light-years. This diagram shows the entire 93 billion light-year diameter of the observable universe. The Great Wall alone consumes more than 10% of that entire span. A structure of this magnitude presents a massive problem for astrophysics. According to our current models of how matter clusters together, an object this large shouldn't exist. Its presence shatters the assumption that the universe is uniform on its largest scales. The rule in question is the cosmological principle. This is the assumption that the universe is homogeneous, meaning it has a roughly even distribution of matter and looks the same everywhere on a massive scale. In the early 20th century, pioneers like Edwin Hubble relied on these models of even distribution to map the expansion of the cosmos. This chart illustrates the mathematical constraint born from that principle. Because matter can only clump together so much before gravity evens it out, astrophysicists calculated a strict maximum size for any cosmic structure, 1.2 billion light-years. For decades, observations matched the math. Measured galaxy clusters consistently peaked safely below this 1.2 billion light-year ceiling. If an object breaches that threshold, the assumption that the universe is smooth and uniform must be discarded. In 2003, researchers discovered the Sloan Great Wall, a galactic filament measuring 1.38 billion light-years across. 9 years later, the huge large quasar group appeared in the data, reaching 4 billion light-years in length. By 2015, the giant GRB ring, a regular formation of explosions, pushed the scale to 5.6 billion light-years. This sequence of discoveries set the stage for one final, massive outlier. You cannot simply look through an eyepiece and see the Hercules Corona Borealis Great Wall. Its immense distance, combined with the obscuring dust in our own galaxy, makes it invisible to traditional optical telescopes like Hubble. To find it in 2014, researchers mapped gamma-ray bursts, extremely energetic explosions typically generated by the collapse of a massive star's core. Because massive stars often reside in dense galaxy clusters, charting the locations of these bursts gives us a map of where matter is concentrated. When astronomers plotted this distribution across the sky, they found a dense concentration of bursts in one specific direction. This clustering of high-energy explosions outlined a continuous structural formation spanning exactly 10 billion light-years. This mapping technique confirmed a structure that stands nearly 10 times larger than the calculated maximum. Such a massive deviation has sparked heavy debate. Many astronomers argue that this grouping of gamma-ray bursts does not represent a single connected structure. This leaves the scientific community with a choice. Either the methodology for interpreting gamma-ray burst clustering is flawed, or the cosmological principle is dead. Accepting the Great Wall means unlearning a century of assumptions about the structure of our universe. We exist in a reality where light itself takes 10 billion years to travel from one end of a single object to the other. Placed against the sheer mass of this cosmic web, the Earth, our solar system, and the entire Milky Way galaxy are effectively non-existent. If our rules for a uniform universe are broken, and structures this impossibly large can hide in the data, what else is out there, lurking beyond the cosmic horizon, waiting to be discovered?